Are we alone?
There's a camera. It hangs 250 miles above us, bolted to the exterior of the International Space Station, pointing toward the infinite. 24 hours a day, 7 days a week, it streams footage of our planet. A silent witness to sunrise after sunrise, thunderstorms flickering across continents, and the slow dance of auroras painting the poles. Most of the time, nothing unusual happens. And then, one day last autumn, something did. For 47 seconds, between 0314 and 0315 UTC, one of NASA's external high-definition Earth viewing cameras captured something that, according to official statements, required further analysis. 47 seconds. Less time than it takes to make a cup of coffee, and then the feed went dark. Now, here's what makes this interesting. NASA's live streams cut out all the time: signal loss, orbital transitions, routine maintenance. There are a dozen perfectly mundane reasons why a feed might drop, but what happened next was anything but mundane. Within hours, the archived segment was flagged. Internal discussions began circulating, and the footage that millions of people could have seen, that fraction of a minute showing something luminous, structured, and moving with apparent purpose across the camera's field of view, was quietly removed from public access. The official explanation: technical evaluation pending. That was 8 months ago. Beat. So tonight, we're going to do what we do best. We're going to look at the evidence. We're going to talk to the experts, the scientists, the engineers, the people who spend their lives studying what we can and cannot explain about the space beyond our atmosphere. And we're going to ask one simple question. What was that? Before we can understand what was captured that night, we need to understand how we capture anything from the ISS at all. The International Space Station is, among many things, one of the most sophisticated observation platforms humanity has ever constructed. Orbiting at approximately 17,500 miles per hour, it completes a full circuit of Earth roughly every 90 minutes. That means every single day, astronauts aboard the station experience 16 sunrises and 16 sunsets. But humans aren't the only ones watching. Mounted on the station's exterior are multiple camera systems, some designed for scientific research, others for public engagement. The High-Definition Earth Viewing Experiment, or HDEEV, was launched in 2014 and operated until 2019. It consisted of 4 commercial HD video cameras enclosed in a pressurized housing, streaming live footage of Earth back to audiences around the world. After HDEV was retired, NASA continued using other external cameras for both research and live public feeds. These cameras operate continuously, streaming to YouTube, NASA TV, and various partner platforms. Most of the time, they show exactly what you'd expect: cloud formations, city lights at night, the Terminator line creeping across continents as Earth rotates beneath the station. But every so often, something else enters the frame. Now, to be absolutely clear, and this is important, the vast majority of anomalies captured by ISS cameras have perfectly reasonable explanations. Ice crystals breaking off from the station's cooling systems, debris from spent rocket stages or satellites, lens flares from the sun, even the station's own solar panels reflecting light in unexpected ways. These are not mysteries. They are the predictable byproducts of operating complex machinery in the harshest environment known to humanity. But what happened on the night in question doesn't fit neatly into any of those categories. And that's what caught people's attention. The timestamp reads 031422 UTC. The camera is pointed away from Earth toward open space. The station is passing over the Pacific Ocean, in the shadow zone where the sun hasn't yet risen. The only illumination comes from starlight and the faint glow of Earth's atmosphere on the distant horizon. For the first 12 seconds, nothing happens. The frame is still. Stars drift slowly as the station's orbital path carries it forward. And then, at 3:14:34, a light appears. It doesn't fade in gradually. It doesn't streak across the frame like a meteor. It simply appears. A single luminous point, roughly 3 times brighter than the background stars, positioned approximately 15 degrees above the horizon line. For 6 seconds, it remains stationary. Then it begins to move. The movement is slow at first, a gentle drift toward the upper left of the frame, but within seconds it accelerates. Not erratically, not in the jagged, tumbling pattern you'd expect from debris caught in orbital decay. This movement is smooth, controlled. It follows a curved trajectory that, according to later analysis, does not match any known satellite or debris object in the publicly available tracking catalogs. For 18 seconds, the object moves steadily across the frame. And then, at 3:14:58, something extraordinary happens. It stops. Not gradually, not with the inertia you'd expect from an object in microgravity. It simply ceases forward motion, hovering, if that word can even apply in the vacuum of space, in the upper portion of the frame. It remains motionless for 4 seconds. And then, at 3:15:02, it pulses. Once, twice, 3 times in rapid succession. The brightness increases by approximately 400%, then fades back to its original luminosity. And then, as suddenly as it appeared, it accelerates again. This time at a velocity that takes it out of frame within less than 2 seconds. The final timestamp on the footage reads 03:15:09, 47 seconds in total. And at 3:15:11, the live feed cuts to the standard NASA placeholder screen. The high-definition Earth viewing experiment is either switching cameras or experiencing temporary signal loss. Except, according to station telemetry logs later obtained through Freedom of Information requests, there was no signal loss. The feed was manually interrupted. Within 24 hours of the incident, questions began circulating online. Viewers who had been watching the live stream noticed the cut. Some had screen recorded the footage before it disappeared from the archive. Others had taken screenshots. By the end of the week, the clip had been viewed over 4 million times across various platforms. NASA's initial response was measured. A spokesperson for the agency issued a brief statement explaining that the footage was under review and that such interruptions were not uncommon, given the technical complexity of maintaining live feeds from orbit. Fair enough. That's true. But when pressed for details about the specific object visible in the footage, the agency declined to comment further, citing the need for thorough analysis before public statements. That analysis, according to NASA, is still ongoing. Now, let's be careful here. It would be easy, and tempting, to interpret this as a cover-up. To assume that the silence means something is being hidden. But that's not how science works. And it's not how we're going to approach this. What we can say, objectively, is this. The footage shows something unusual. The behavior of the object, its appearance, its movement, its apparent stopping and acceleration, does not match the known characteristics of common orbital debris, satellite passes, or natural phenomena like meteors. That doesn't mean it's inexplicable. It means we don't yet have a complete explanation. And in science, that distinction matters. To understand what might have been captured that night, we reached out to several experts in orbital mechanics, atmospheric physics, and optical phenomena. Dr. Marcus Heller, a retired aerospace engineer who spent 18 years working on satellite tracking systems for the European Space Agency, offered this perspective. The behavior described, the sudden stop, the apparent pulsing, the rapid acceleration, is unusual but not necessarily impossible to explain. Space is full of reflective objects, and the way light interacts with them can create illusions of movement that don't match actual trajectories. A tumbling piece of debris, catching sunlight at just the right angle, could theoretically produce a pulsing effect. The question is whether the timing and pattern match what we'd expect from random rotation, and in this case, the regularity of the pulses is intriguing. He paused before adding, "That said, I'd want to see the full telemetry data before making any conclusions. The human eye and camera sensors can be deceived." Dr. Elena Vasquez, an astrophysicist specializing in upper atmospheric phenomena at the University of Colorado, offered a different angle. One thing people often forget is that the space around Earth is not empty. We're surrounded by a complex environment of charged particles, plasma, and electromagnetic fields. Under certain conditions, these can produce optical effects that look artificial, but are entirely natural. Ball lightning, sprite phenomena, even certain types of aurora can create localized, structured light emissions that seem to move with purpose. When asked whether such phenomena could explain the footage, she was cautious. "I'd need more data. The altitude, the solar activity at the time, the magnetospheric conditions, all of these matter. Without that context, I can't say definitively what it was, but I also can't say definitively what it wasn't." And then there's the third perspective, one that's harder to dismiss, even if it's harder to prove. Dr. Kevin Knuth, a professor of physics at the University at Albany who has published peer-reviewed research on unidentified aerial phenomena, put it this way: "We have historically been very reluctant to consider the possibility that some of these sightings represent something genuinely novel, something outside our current understanding. That reluctance is understandable. Science is conservative by design, but the data is the data. And when we see behavior that doesn't fit our models, the correct response isn't to dismiss it, it's to investigate." He was careful to add, "That doesn't mean every anomaly is evidence of something extraordinary. Most aren't. But closing the door to inquiry is not the same as proving something mundane." Here's the thing. This isn't the first time something unusual has been captured by ISS cameras, and it won't be the last. Over the years, viewers and researchers have documented dozens of instances where the live feed showed objects that didn't match known spacecraft, debris, or natural phenomena. Some of these have been explained, retroactively identified as resupply vehicles, satellite passes, or equipment malfunctions. Others remain unexplained. In 2016, footage from the station appeared to show a small, bright object ascending from Earth's atmosphere before the feed cut out. NASA attributed the object to a reflection, but the explanation left many observers unconvinced. In 2020, a slow-moving triangular formation of lights was visible in the background of a routine crew activity broadcast. The formation remained stable for nearly 3 minutes before drifting out of frame. No official comment was ever issued. And in 2022, during a routine spacewalk, one of the astronaut-mounted cameras captured what appeared to be a metallic disc-shaped object passing at high speed in the distance. The footage was included in the official EVA archive, but was never addressed publicly. Now, none of this proves anything definitive. Individually, each incident can be attributed to camera artifacts, debris, or optical illusions. But collectively, they suggest that the space around Earth is more active and more mysterious than we've been led to believe. Let's engage with the question seriously. If, and this is a significant if, the object captured in the footage represents something artificial, something manufactured by an intelligence, what would it take to produce the behavior we observed? The sudden stop is the most challenging aspect to explain. In the vacuum of space, where there's no friction and no resistance, an object in motion stays in motion unless acted upon by an external force. That's Newton's first law. It's fundamental. For something to stop suddenly, to go from steady velocity to complete stillness in a fraction of a second, would require the application of an enormous force in the opposite direction. The kind of force that, with our current technology, would be visible: thruster burns, propellant expulsion, some evidence of the mechanism at work. The footage shows none of that, which leaves us with a few possibilities. The first is that the stop was an illusion, a trick of perspective caused by the object's trajectory intersecting with the camera's line of sight at just the right angle. This is theoretically possible, though the smoothness of the preceding and following motion makes it difficult to reconcile. The second is that the object was using a propulsion system we don't understand, something that operates without visible exhaust or reaction mass. This is obviously speculative, but it's worth noting that theoretical physicists have proposed concepts like the Alcubierre drive and various electromagnetic propulsion systems that could, in principle, produce movement without conventional thrust. We're nowhere near building such systems, but that doesn't mean they're impossible. The third possibility, and this is the one that makes scientists most uncomfortable, is that we're looking at something we simply don't have a framework to understand yet. Not a lack of data, but a lack of conceptual models. Dr. Michio Kaku, the theoretical physicist and popular science communicator, has often said that any sufficiently advanced technology would be indistinguishable from natural phenomena to an observer without the proper context. We might be watching something extraordinary and not even realize it, interpreting it through lenses that were never designed to see it. That thought should humble us. Throughout history, explorers have brought back stories of things they couldn't explain. Sailors spoke of strange lights on the horizon. Pilots reported encounters with objects that defied the laws of aerodynamics. And astronauts, though they rarely speak publicly about it, have, according to numerous accounts, observed phenomena in orbit that made them question what they thought they knew. In 1965, astronaut James McDivitt photographed a cylindrical object with a protrusion during the Gemini 4 mission. He described it as something out there that he couldn't identify. NASA later suggested it might have been a piece of the spacecraft itself, though McDivitt remained uncertain. In 1969, during the Apollo 11 mission, the crew reported a light traveling alongside them for a portion of the journey. The object was eventually attributed to a detached spacecraft panel reflecting sunlight, a plausible explanation, though one that required significant reconstruction of the timeline. And more recently, in private conversations that have only come to light through memoirs and interviews, several ISS crew members have described moments of quiet astonishment, looking out the cupola windows and seeing something that, for just a moment, made the universe feel stranger than they expected. Beat. We don't talk about these moments often. They're not peer-reviewed. They're not measurable. They're human experiences filtered through memory and emotion. But they matter, because at the end of the day, science isn't just about data. It's about wonder. It's about the willingness to stand at the edge of what we know and ask, honestly, what else might be out there? The timing of this incident is worth considering. In recent years, the conversation around unidentified aerial phenomena, UAP, the modern successor to the term UFO, has shifted dramatically. What was once dismissed as fringe speculation has become the subject of congressional hearings, Pentagon reports, and serious scientific inquiry. In 2021, the U.S. Office of the Director of National Intelligence released a preliminary assessment acknowledging that military personnel had encountered objects that probably do represent physical objects, and that a handful of cases appeared to demonstrate advanced technology. In 2023, former intelligence officials testified before Congress, claiming that the U.S. government had been in possession of non-human craft and biological materials for decades. These claims have not been independently verified, but they've sparked renewed interest in historical cases and encouraged greater transparency. And in the scientific community, organizations like the Galileo Project at Harvard and the Sol Foundation have begun applying rigorous methodology to the study of anomalous phenomena, treating them not as mysteries to be dismissed, but as data to be analyzed. Dr. Avi Loeb, the Harvard astrophysicist who leads the Galileo Project, has been vocal about the need for open inquiry. Science advances by examining evidence, not by ignoring it. If there are objects in our atmosphere or in orbit that we cannot explain, then we have an obligation, as scientists, as curious beings, to find out what they are. The alternative is willful ignorance. This shift in attitude may explain why the ISS footage, despite being removed from public archives, has not been forgotten. Because the world is paying attention now. Let's take a step back. The universe is approximately 13.8 billion years old. Our solar system is roughly 4.6 billion years old. Homo sapiens, our species, has existed for about 300,000 years. In that cosmic timeline, we are infants. Our technological civilization is barely a century old. Radio transmission, spaceflight, computer networks, all of it developed within the span of a few generations. And yet, in that blink of cosmic time, we've already begun to reach beyond our planet. We've sent probes to the outer solar system. We've listened for signals from distant stars. We've walked on the moon and driven rovers on Mars. Imagine what a civilization might accomplish with 1 million years of development. 10 million, a billion. Beat. We assume, often unconsciously, that we are the pinnacle, that our understanding of physics, our models of the universe, represent the final word on what's possible. But history teaches us otherwise. A century ago, we didn't know other galaxies existed. 50 years ago, we hadn't discovered exoplanets. 20 years ago, we couldn't detect gravitational waves. What will we understand a century from now? What are we missing right now? One of the challenges with footage like this is that it exists in a gray zone. It's not proof of anything extraordinary. A few seconds of video, captured by a camera that wasn't designed for high-precision observation, can only tell us so much. Sensor limitations, compression artifacts, lighting conditions. All of these introduce uncertainty. And yet, it's also not nothing. The footage shows an object with characteristics that don't fit standard explanations. The behavior, the stopping, the pulsing, the acceleration, suggests something other than passive debris or random reflection. That doesn't mean we should leap to conclusions. It means we should ask questions. What other sensors were active at the time? Did radar stations or ground-based observatories detect anything in the same orbital region? Is there satellite telemetry that could provide additional context? These are the questions that responsible inquiry demands. And these are the questions that, so far, remain unanswered. NASA's continued silence is not, in itself, evidence of anything. Agencies move slowly. Analysis takes time. And there are legitimate reasons why sensitive data might be withheld from public release. But the silence is also not satisfying. Not when the footage is already in circulation. Not when millions of people have already seen it. At some point, the public deserves an explanation. Even if that explanation is, we don't know what this is, and we're still trying to figure it out. That kind of honesty would go a long way. There's something about footage like this that touches a deeper part of us. It's not just about lights in the sky. It's not just about scientific curiosity. It's about our place in the cosmos. For thousands of years, humans looked up and wondered. We built myths around the stars. We imagined gods and spirits inhabiting the heavens. We told stories to make sense of the vastness. And then, gradually, science began to replace myth. We learned the sun was a star. We discovered that the universe was unimaginably large. We realized that Earth was not the center of anything, just one small world, orbiting one ordinary star in one unremarkable galaxy among trillions. That knowledge should have diminished us. In a way, it did. But it also opened a door. Because if the universe is that vast, if there are more planets than grains of sand on every beach on Earth, then the question isn't whether we're alone. The question is why we would assume we are. The footage from the ISS, whatever it ultimately shows, is a reminder of that question. A reminder that the universe doesn't owe us certainty. That discovery often begins with moments of confusion, with data that doesn't fit, with the willingness to say, I don't know yet. And there's something beautiful in that. Let's consider for a moment what it would mean if, and again, this is speculative, the object captured that night was something genuinely novel, not debris, not a satellite, not a natural phenomenon, something else. The implications would be profound. First, it would suggest that the space around Earth is not as empty as we assume, that there may be objects, vehicles, or phenomena operating in our orbital neighborhood that we are not aware of. From a national security perspective alone, that would be significant. Second, it would challenge our assumptions about what's possible. The behavior of the object, if accurately captured, implies capabilities that exceed our current technological understanding. Propulsion without visible exhaust. Sudden changes in velocity that would require forces we cannot produce. These are not minor discrepancies, they are fundamental. And third, it would force us to confront a question we've been avoiding. If we're not alone, what does that mean for us? Beat. This isn't about panic. It's not about fear. It's about reckoning with the possibility that the universe is more complex, more inhabited, and more mysterious than the comfortable models we've constructed. That reckoning, if it comes, will be one of the most important moments in human history. 8 months have passed since the footage was captured. 8 months of silence, 8 months of speculation, 8 months of waiting for an answer that may never come. And yet, the footage remains. The questions remain. The curiosity that drives us to look up, to wonder what else might be out there, remains. That's the thing about moments like this. They don't resolve neatly. They don't offer the satisfaction of closure. They leave us in a state of productive uncertainty, aware that we've seen something unusual, but unable to say definitively what it was. And maybe that's okay. Maybe that's even the point. Because science isn't about having all the answers. It's about being willing to ask the questions, even when the answers are uncomfortable, even when they challenge what we thought we knew. The footage captured by the ISS that night is a question. A 47-second question beamed down from the edge of space. And we're still waiting for the answer. The universe is vast, ancient, indifferent to our need for understanding. It doesn't care whether we solve its mysteries or not. But we care. We've always cared. From the first humans who looked up at the night sky and wondered, to the scientists and engineers who built the stations and telescopes that extend our vision into the cosmos. We are a species defined by curiosity, and that curiosity is more powerful than fear, more durable than doubt, more important than any single answer. So what was captured that night? Honestly, we don't know, but we're going to keep looking. If discoveries like this fascinate you, if you want to explore the mysteries of space, the questions we're still asking, and the wonders we're only beginning to understand, consider subscribing. The universe is just getting started. And so are we. Thank you for watching. If this video made you think, share it with someone who looks at the stars and wonders. Until next time, keep looking up.